Good morning, good afternoon, and good evening to you all. I am Mr. Jan, and we are gonna learn inscribe angles and inscribe polygons. But first, let's learn what is angles and polygons. First and foremost is angle. An angle is an endpoint of two sides. Basically, it's where two lines intersect each other. For example, these two lines, this part where the two lines intersect, this is where the angle is. This is the angle. Next is polygon. A polygon is formed by connected lines to form a closed polygonal chain. In other words, it's a shape that have edges. For example, triangles and squares. Like this. This is a polygon. Or even this is a polygon. But this is not a polygon. Now, since we already know what's angle and a polygon, now let's learn what is an inscribed angle. Inscribed angle is an angle formed inside the circle when two chords intersect. Like, for example, this circle. These two lines are chords. Well, chords are lines that intersects the circle but does not touches the point of the circle. Now, where they intersect is called the inscribed angle. Right here. And the arc where they intersect is called the intercepted arc. Now, when it is on the point of the circle where it came from, or is formed by two radius, it's gonna be called a central angle. If you guessed that it's 6, then you would be correct. And also, if you notice, its endpoints are on the circle. See? Now, here are some theorems that will help us understand the angles inside or outside the circle. First is inscribed angle theorem. The inscribed angle is half the central angle that intersected the same arc. The measure of the intercepted angle is half the measure of the intercepted arc. For example, the inscribed angle is equal to the half of the central angle, while the central angle is equal to the intercepted arc. Like, if the size of these is 50 in this, and what would be the size of this and this? Exactly this, both of them would be also 100 and 100, because inscribed angle is equal to the half of the central angle and intercepted arc. Next theorem is angle in a semicircle theorem. Angle inscribed in a semicircle is a right angle. For example, is this. The angle in here will always be 90 degrees because it came from a semicircle or a diameter. This part here, this line that intersects the circle in half, which it touches the point. Next is inscribed quadrilateral theorem. Opposite angles of an inscribed quadrilateral are supplementary, means opposite angles combined equal half the quadrilateral. For example, if you have a square right here, if you add both of its four angles, it's gonna be equal to 180, while being each angles having different measures. For example, this circle, if you add all of its angles, it will equal to 360, since that's the size, the angle measurement of a quadrilateral. But if you say triangle, that would be 180. In the next one, we're going to use everything that we had learned into one question. Let's answer this using everything that we have learned. First is the angle in a semicircle theorem. You can use it since this part must be 90 degrees, since this is a semicircle. Half of the 90 degrees is 45 degrees. That also applies in A, C, and D. CAD, that must be 90. And next is OBD, which I forgot. There's an O here. OBD, since this is a central angle and it's a diameter, this is 90, since it's half 180 degrees. Next is ABO. ABO, which is the whole line. This is not an angle, man. This is a line. This is 180. And C, which is an angle in a semicircle, 90. And A plus D, which is both are 90 80 degrees will also equal 180. Okay, now a quick recap of what we have learned. This is the inscribed angle theorem, which is inscribed angle is equal to the half of the intercepted arc. Angle in a semicircle theorem, which is a semicircle always equal to 180 degrees. And the inscribed quadrilateral theorem, which says that the opposite angles of a quadrilateral is equals to 180. For example, angle D and angle B is equal to 180. That's all it, guys. Thank you for watching and see you next time.